So we cannot talk about data science, and certainly not this course, without talking about Python. Python is a programming language that was created in 1991, and so it's been around for a while already. Now, Python is not named after the snake, that's a little trivia. It's actually named after the Monty Python. And I can relate to this because I really enjoyed the Monty Python. And in fact, a lot of the documentation of Python, is, if you read it, is written in a very absurd, silly way to mimic the Monty Python style. So this is all very good. But what is Python? Well, Python is an interpreted language. Interpreted means it's not compiled. So it's not transformed into bytecode that the computer can immediately read. Instead, we have a program that runs called the interpreter, and you give command to the interpreter. And the interpreter takes your command, reads it, and then goes and executes it. Now that's great because it gives you flexibility. And in the 90s, it was the only way you could have this kind of flexibility where you could just write a line of code, execute it, see the result, use the results, write another line of code, and execute it. And that principle is one of the key successes of Python because it's an interpreted language. Python is also what is known as a strongly typed language. So let me show you what strongly typed means. So if I declare a variable in Python, in this case I've declared x to be equal to 3, it has a type. So now if I want to know the type of the variable, I can just type and x being my variable, and the return is an integer. That means that Python knows what its variables are. It knows in this case that it's dealing with an integer and not with a double precision float number, for instance. And it definitely is not dealing with a string, which would be a sequence of characters. And that's important because you can do more efficient operation on a type that you know. It's very difficult to do operation on a type that you don't know. So that's all good. But Python is also known as a dynamic language. So let's see now what this means. In a dynamic language, I can change the type on the fly. So for instance, now I could declare x to be hello geosciences. And if I run this, I get no error. So flexibility is key here, and that's great because, I'm not constrained by the type of the variable. I can still do something with it that is maybe different than my original intention. But problem can arise with this type of practice because what happens if I want to multiply x by 2 now? Let's say I forgot that I've reassigned x to a string and now I do x times 2. And what I get is an unexpected result. Instead of obtaining 6, which would have been the original answer, I obtain a string that is a combination of two strings. Hello geosciences, hello geosciences. And that's the problem with dynamically typed languages. By opposition, statically typed languages don't allow you to do this. Let's look at an example in Scala. So in Scala here, I've defined my value, x equals to 3. And if I multiply x by 2, I obtain the results that I expect, 6. But now if I try to define x as hello geosciences, let's see what happens. I get a compilation error. That means that the statically typed language, once you've created your variable, does not allow you to change the type of the variable. And that's really the fundamental difference. That seems like a very small difference, but it's actually a huge difference because it allows the language to optimize for the type of your variable. So it's much faster, it's better, it's more memory efficient, but it also avoids bugs because I cannot somewhere in my code change the variable from a type of integer to a type of string. So that's really the thing with Python. It has strengths that are also its weaknesses. One of its strengths is to be dynamic and to be flexible, but one of its weaknesses is to be dynamic and flexible. Sometimes it's too dynamic, too flexible, so it really depends on you as a coder to be disciplined and to not misuse the type. And it's easy to do if you're alone on a small project. It's much harder to do if you do a very large project or if you're multiple coder on the same project. So that's a big problem. The other weakness of Python is that it's very slow because it's interpreted. Scala, by opposition, is compiled, even though now you can do the same dynamic feel that you have with Python. That's the modern languages today that allow you to do this. It is a compiled language. So by definition, it is faster. So that's one of the weaknesses of Python as well. It's the speed of the execution. But we'll see that there's ways around this when we talk about NumPy and other libraries, because effectively Python is not that much slower thanks to the way those libraries are designed. But why are we using Python if it is a language that basically has flaws? Well, first of all, every language has flaws. Python is not the best language, but Python has a simple syntax, which makes it very easy to learn. And that's why it attracted a lot of scientists, a lot of people that are not by definition coder, went to Python because the entry level, the bar to go into coding is easier. And by extension, that gives it really its biggest strength, which is the ecosystem. The number of libraries that exist in Python is tremendous. And in fact, most of the data science library are written in Python or for Python. And this is why Python is the #1 language for data science.